I want you to imagine something. You are in a spaceship, the fastest spaceship ever built, moving at the speed of light, 300,000 kilometers every second. You left Earth behind long ago. You passed the moon in just over a second. You passed the sun in 8 minutes. You have been traveling for years, and then decades, and then centuries, past stars, past galaxies, past clusters of galaxies so vast that our entire Milky Way is just one tiny point of light among hundreds. And you are still going, faster than anything, further than anything, toward the edge. Tonight, the question is simple. What happens when you get there? Welcome to Wonder Drift Stories. If these stories help you sleep, a like and a subscribe means everything to this small channel. New stories every week. Now, let us find the edge. Here is the first extraordinary thing. There may not be one, not a wall, not a boundary, not a place where space ends and something else begins. The universe may simply go on forever. This is not a poetic idea. It is a scientific one. When cosmologists measure the large-scale curvature of space across the universe, using the most precise instruments ever built by human hands, they find something remarkable. Space is flat, not curved like the surface of a sphere, not curved like a saddle, flat, like an infinite sheet of paper extending in every direction without end. And a flat universe is an infinite universe, which means there is no edge to reach. No matter how fast you travel, no matter how long you go, there is always more space beyond. Always another galaxy, always another cluster, always more, forever. Let that settle for a moment. Not just very large, not just unimaginably large, infinite. The universe is infinite, and our entire observable universe, all 93 billion light years of it, is just one small, finite patch of something that goes on without end. But here is where it gets stranger. Even if the universe is infinite, even if space goes on forever in every direction, there is still something that functions like an edge. Something we cannot see past, something no telescope can ever penetrate. It is called the cosmic horizon, and it is one of the most profound ideas in all of science. Here is how it works. The universe is 13.8 billion years old. Light travels at a finite speed. That means the furthest we can ever see is the distance light has been able to travel since the very beginning of time. about 46 billion light-years in every direction. This is our observable universe, the sphere of space from which light has had time to reach us. Beyond that sphere, space continues, galaxies continue, but their light has not yet reached us. It is still traveling. It left home billions of years ago, and it is still crossing the void between there and here. And depending on where you are in the universe, your observable universe is centered on you, completely. Every observer in the universe sits at the exact center of their own observable universe. An alien intelligence in a galaxy 40 billion light-years away looks out at their own sphere of space and sees themselves at the center, just as we do. There is no privileged position, no center of the universe. Every point in space is simultaneously at the center of its own cosmic horizon. And yet, we are all looking at different things. Now here is the fact that stops physicists in their tracks. The universe is not just large, it is expanding every second of every day. Space itself is stretching. The distance between galaxies is growing larger, not because galaxies are flying apart through space, but because the space between them is being created. New space, appearing between every galaxy and every other galaxy, continuously, right now, as you rest. And here is the devastating consequence of that. The expansion of the universe is accelerating. Whatever is driving the expansion, scientists call it dark energy, which is really just a name for something we do not understand at all. It is pushing space apart faster and faster with every passing moment. And because of this acceleration, there are galaxies we can see right now that we will never be able to reach, ever. Not because they are too far away, but because the space between us and them is expanding faster than the speed of light. They are moving away from us faster than light can travel. Which means, even if you left Earth today in that perfect spaceship traveling at the speed of light, you would never arrive. The destination would always be receding faster than you approach. These galaxies are visible to us right now. We can see them. We can photograph them. We can study their light, but we can never reach them. And as the universe ages, as the expansion continues to accelerate, more and more galaxies will cross this threshold. More and more of the universe will move beyond our reach, not because they disappear, but because the space between us grows too fast for any signal to ever bridge it. In the very far future, trillions of years from now, almost all of the galaxies we can see tonight will have crossed beyond our horizon forever. The night sky will be nearly empty. Future civilizations, if any exist, will look out and see almost nothing. No galaxies. No evidence that anything exists beyond their own. They will have no way of knowing what we know tonight, that the universe is vast and full and infinite. We are living in the golden era of cosmology, the only moment in the history of the universe when the sky looks exactly like this. Let us go back to your spaceship. You have been traveling for billions of years. You are approaching the edge of our observable universe, the cosmic horizon. What do you actually find there? Nothing dramatic, no wall, no darkness suddenly beginning, no sign that says you are now leaving the observable universe. Space looks the same as it did a billion light years ago. Galaxies in every direction, stars being born, the same darkness, the same cold, the same vast silence punctuated by the slow burning of stars. The only thing that changes is that the light from those galaxies is increasingly stretched. As space expands, the wavelengths of light traveling through it get stretched too. Light that started its journey as visible light arrives at your eyes as radio waves, invisible, cold. The energy drained from it by 4 billion years of travel through expanding space. This is called redshift, and at the very edge of the observable universe, the redshift is so extreme that the first light ever emitted, the light from the very first atoms, released 380,000 years after the Big Bang, arrives at our telescopes not as visible light, but as faint microwaves. The cosmic microwave background. That ancient glow we mentioned in our very first episode. The last photons from the cosmic fog that filled the early universe. Still traveling, still arriving, still reaching us. From the edge of everything we can see, from 13.8 billion years ago, a whisper from the beginning of time, reaching us every night as we sleep. But what if the universe is not infinite? What if it is finite, large beyond any human comprehension, but finite? This is also scientifically possible. And if the universe is finite but has no edge, which general relativity allows, then something extraordinary becomes possible. The universe could be shaped in such a way that, if you traveled far enough in one direction, you would eventually come back to where you started. Not because you hit a wall and bounced back, but because the geometry of space itself curves around and closes, like the surface of the Earth. If you sail east from any point on Earth for long enough, you come back from the west. You never hit an edge. There is no wall. The surface simply curves back on itself. The universe could do the same thing in 3 dimensions, which would mean that if our telescopes were powerful enough, we might look out into deep space and eventually see the back of our own galaxy, our own Milky Way, as it was billions of years ago, its light having traveled all the way around the universe to reach us from the other direction. We have not found this yet, but we have not ruled it out. The universe remains beautifully, stubbornly unknown. There is one more thing to consider. When cosmologists say the observable universe ends at 46 billion light-years, they are describing the limit of what we can see. But there is another horizon, a harder one, the cosmic event horizon, about 16 billion light-years away. This is the boundary beyond which light emitted today will never reach us, not in a billion years, not in a trillion, not ever. Because the space between us and that boundary is expanding faster than the light can cross it. We are being separated from a portion of the universe right now, permanently, irreversibly, and nothing can stop it. There are galaxies tonight whose light is reaching us, galaxies we can photograph and measure and study that we can never communicate with, not even in principle. We could send a message at the speed of light toward one of those galaxies right now, and it would never arrive. The galaxy would always be receding faster than the message approaches. We are watching ghost images, light that left home before that boundary was crossed, arriving here, telling us about a place we can never go, a universe we can never reach, but which is real and vast and continuing without us. Now here is the most extraordinary thing of all. Beyond our observable universe, beyond the cosmic horizon, beyond everything light has been able to show us, the universe continues. We believe this, not as faith, as science. The same physics that governs our observable universe must continue beyond our horizon. The same atoms, the same forces, the same laws, stars forming around the same elements, planets cooling in the same darkness, life, perhaps, looking up at its own night sky, wondering exactly what we are wondering, whether there is an edge, what lies beyond it, whether anyone else is asking the question. The universe is so large that whatever is possible is almost certainly happening somewhere, right now, while you sleep. In a patch of space you can never see, on a planet you can never know. Creatures you can never imagine are perhaps looking up at their own impossible night sky and feeling exactly what you feel right now. Small, vast, part of something incomprehensibly large, and yet somehow completely at home in it. There is no edge, or if there is, we can never reach it, or if we could reach it, it would look just like everywhere else. Space continuing, stars burning, the same silence, the same dark. The universe offers no walls, no exits, no signs telling you that you have arrived somewhere final. Only more space, only more time, only more of the same beautiful, indifferent vastness that has been here since before there was a here. And here is what I find most comforting about all of this. You are not small because the universe is large. You are the part of the universe that knows it is large. You are the part of the universe that asks what is at the edge, that wonders what lies beyond the horizon, that lies in the dark at night and reaches out with its mind towards something it can never physically touch. No telescope has ever done that. No galaxy, no black hole. Only you. Only this. Only now. The universe is infinite, or close enough to infinite that the difference does not matter. And in all of that infinity, you are the part that wonders about it. That is not nothing. That is everything. Close your eyes a little more. Let the edges soften. Let the questions drift. You do not need to find the edge tonight. It will still be there tomorrow and the next night and every night after that, for as long as there are nights, which according to the best science we have is a very long